Hello everyone. So on this video, I am going to introduce the inflation formulas to you. So number one, we all know the inflation formula, which is new CPI minus old CPI divided by old CPI times 100. So here, there's an example. So let us assume that in 2012, the CPI was 114. And let us assume that in 2028, the CPI was 108. So if we were to calculate the inflation rate here, we're simply going to say new CPI, which is 108, minus the old CPI, which is 114, divided by the old, which is 114, and we multiply everything by 100. The answer that we're going to get here is negative 5.26%. Now, I know that when we see this negative sign over here, some of us are going to start to panic. But please don't panic, because in economics, whenever you see a negative sign, it is just showing you that there was something that was decreasing there. In this case, it is just telling us that the inflation actually decreased by 5.2%. The last two formulas are actually formulas about real variables. So formula number one here says nominal variable divided by price. So we usually use this formula when we want to see the effect that the change in price has on our nominal variable. So for example, suppose in 2020 you earned $10 and candy cost $1 per piece. So the nominal variable here is going to be 10 and the average price is going to be 1. So if we put those values in our calculator, we're going to get 10, which means that with our salary, we were able to buy 10 candies in 2020. Now, in 2025, you earn $12. We can see that there was an increase in our salary, but also the candy increased from $1 to $2. So in 2025, the nominal variable was 12 and the average price was 2. So our answer is going to be 6. So just by calculating here, we can then tell that the $2 increase on our earnings or on our wages is actually worthless, because in 2020 we were able to buy 10 candies, but in 2025 we are only able to buy 6 candies. The last formula, which is nominal variable divided by CPI times 100. So we use this formula when we actually want to check the effect that inflation has on our salaries or on our investments. So without wasting time, we can see here that in 2015, our salary was 50,000 and the CPI for that year was actually 100. So if we calculate here, the nominal variable is going to be 50,000 divided by 100 and multiplied by 100. So our answer is going to be 50,000. So there was no effect, right? If we go to 2025, we then see that the salary increased to 65,000, but the CPI also increased from 100 to 130. So here, our nominal variable is going to be 65,000 divided by 130 multiplied by 100. The answer is 50,000. There's something that I want to talk about, guys, here. I actually want to talk about the base here. The base here is always 100. Keep this in mind. The base here is always 100. Now, someone might ask, why is my nominal variable equals to the real variable? Yes, the reason why that is happening is because in the base here, there is no inflation. We actually use the base year as a reference point, which means we compare all the other years to the base year. So during the base year, this example is actually showing us that the nominal variable is actually equal my real variable.